Alright, this video is going to cover scientific notation. It's a way of writing really big and really small numbers. And it involves two items, two numbers and an expression. We have this 4.5 times 10 to the power of 7. Your first number is always going to be between 1 and 10. And the second number that's being multiplied is always going to be an exponent, a base 10 exponent. Now there's a long way you could do this where you could literally work out 10 to the 7 and then multiply that by 4 and 5/10, but there's a trick, and that's what we're going to talk about in this video. If you have a positive exponent in the number, you slide the decimal that many places to the right. Now the mistake a lot of kids make is they go, oh, I'm just going to need 7 zeros. They see that exponent of 7 and they think 7 zeros because they probably had the powers of 10 exercise where that works. With this problem though, you don't think of it as 7 zeros. You think of it as the decimal is going to slide 7 places to the right. So we have our 4, 5, and we have the decimal currently between the 4 and the 5. It's going to slide 7 places to the right. One of those places is already taken by that digit of 5. So you're going to slide 7 places to the right, but you're only going to need 6 zeros. So then the decimal slides. So when you write this out properly, you're going to have a 45 with 6 zeros. That's going to be 45 million. The next one. Once again, you've got a number times 10 to the 4th, and in this case you're going to slide it 4 places to the right. You're going to take your decimal and slide it 4 places to the right. You're not going to need 4 zeros though. You're only going to need 2 zeros. You're only going to need 2 zeros to fill this one in because 2 of those places are already taken by the 2 and the 8. So when you do this slide, you're going to have 52,800. So now we have 8 times 10 to the power of 9. With this one, 8 is just a single digit number. There's no decimal after, but you could think of it as 8 point and then nothing. This one, you're going to slide the decimal 9 places to the right. There are no other digits, so in this one you will need 9 zeros. And we have 8 billion. That's how much money you're going to make if you understand this. So now we're going to deal with negative exponents. When you have a negative exponent, instead of sliding to the right, you slide to the left. And this one's real easy. So you're going to have the 9, 3. Your decimal's currently between the 9 and the 3. It's going to slide 6 places to the left. Now a lot of kids might say, oh, well that means you only need 5 zeros. 5 zeros are going to hold the place values, but then you also want an additional 0 in front of your decimal. So when you slide it, there's a total of 1, 2, 3, 4, 5, 6 zeros. 5 of them holding place values between the decimal and the 9, but that 6th 0 is the one out front showing the whole number spot. And that would be 93, and then let's see, tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths, 10 millionths. 93 10 millionths. It's a very, very small number. So we're going to do another one. We have 5 times 10 to the negative 4. So this one you're going to start with 5 over on the right, and the decimal is going to slide 4 to the left. So you're going to need a total of 4 zeros, with the first one holding a place value. So this one's going to be, let's see, we have our place values, tenths, hundredths, thousandths, 10,000ths. So this would be 5 10,000ths. So when we have standard notation and we're putting it into scientific notation, we want to tune into the non-zero part, and we're going to realize, so at the beginning of this presentation we said the first number has to be between 1 and 10, so we can't have it as 34. We're going to think of it as 3.4, 3 4/10. Then it's going to be times 10 to the something. In this case, with the decimal being here, this was 6 place values over. Once again, don't just count the zeros. It's not 10 to the 5th. It's going to be 10 to the 6th. And since this is a big number, this is going to be a positive exponent. 3 4/10 times 10 to the 6. We'll do a couple more. This is a big number. It's going to be a positive exponent. So we focus on this 532. We don't want to use 532. We don't want to use 53.2. We want to use 5.32 because that number is between 1 and 10. There's 3 zeros, but there's an additional 2 place values we need to consider. So it's not going to be 10 to the 3rd. It's going to be times 10 to the 5th. And that's that one. So now we're going to deal with a small number. We're going to look at the 36. We want to think of that as 3.6. Once again, the trick is to just count your zeros. And I see 7 zeros. Now this is a small number, so it's going to be 10 to the negative 7. So that's what happens when you deal with small numbers. And we'll do one more. It's a small number. We have the 3. We're just going to write down a 3. Then we can count the total zeros to the left. And that's going to be a total of 6 zeros. So it's going to be times 10 to the negative 6. So that was a quick overview. Hope it helped.